Okay, we were looking at the biostatistics, and I welcome you to the second lecture. Now, we started to look at the methods of data and result presentation. How do you present your result? We have said we present it in form of tables. You can present it in form of histogram, and you can also present it in form of maps, depending on the type of data that you're presenting. Now, going forward, you can also present your results in form of charts. Okay, for instance, we have the bar charts, and in bar chart you have both the vertical and the horizontal bars. Okay, and you say that bar graph uses rectangular bars to represent the data. They are useful for comparing different categories of variables. Now, when you are presenting your result in charts, whatever form of chart you're using or graph, the labeling or the title is normally written below. Okay. Now we also have the line graphs, and you have the pie chart, and then you have the scattered plot. For instance, in this one you can see the points are scattered. Okay, and we say that the scattered plot plays a role in relationship because between two variables, as a collection of points on the graph. They are useful for identifying patterns or correlation, and that is why when you make this kind of plots, okay, when you make this kind of plots, you will always be requiring what we call the arrow square value. The arrow square value is a regression coefficient that shows you the pattern or the how perfect or how reliable is the data, and your regression value must move between 0 and 1. 0, that there is no pattern at all, and 1, there is a relationship between the two variables you are looking at. It's a perfect relationship. So we always seek out to look out for the arrow square values. Okay, so we can continue to look at other method of presenting results. Now, you can make use of the graphics. Infographics, combines text, images, and visuals to present data in a visual, appealing, and easily understandable format. Okay, so you can see this particular format is actually the infograph. It's showing you a lot of things. You have both your graph, your bar chart, and then some other visuals showing in one particular figure. Okay, now we also have the dashboard. So dashboard is an interactive visual display that provides a comprehensive overview of data. They allow users to explore and analyze data in real time, as with the ability to customize the view and access specific details. Now, for instance, in dashboard, if you're carrying out a research that has to do with bioinformatics, it's necessary that you show the dashboard, because when you show your dashboard, you're going to show the protein and the interactions that are going on, and most at times is also in real time. So the choice of data presented depends presenting method depends on the type of data, the message to be conveyed, and the target audience. Effective data presentation enhances understanding, facilitates decision making, and helps to communicate the insight clearly. Okay, now let's look at data sets and data tables. What is a data set? A data set refers to a collection of data points or observations that are organized or grouped together. It can be thought as a structured and organized collection of related information. Datasets can be derived from various sources, such as survey, experiment, and all that. We have said that they can contain different types of data, including numeric, categorical, and textual data. So, datasets typically consist of two rows, two co- consists of rows and columns where each row represents an individual observation data point. Each column represents a specific variable and attribute. The variable can be quantitative, that is in numbers, or qualitative, that is when it is categorical. Data sets are commonly used in statistics analysis, data mining, machine learning, and other data-driven fields. So let's look at data tables. Data table is a table. Data table is a tabular presentation of data where the data is organized in rows and columns. It is a structured format that allows for easy understanding of analysis of data. Each row in the data table represents a specific observation and data point, and each column represents a variable or attribute. Now, the data table are commonly used to store and manage and analyze data in various fields, including research, business, finance, and more. They provide a way to organize and structure the data, making it easier to search or sort or filter and performing calculations or statistical analysis. In other words, when you want to perform your statistical analysis, you will be looking at the data tables. Now, data table often have columns, column heading, and description of variables or attributes, and each cell within the table holds a specific value corresponding to the intercept of the row and the column. Data table can be created using spreadsheet softwares like Microsoft Excel, Google Sheets, and using programming languages like Python, like R, like SPSS, like GenStat, like AP Info, and so many other statistical package. So you will be learning how to be using data tables. Now let's look at variables. What actually are variables? We've mentioned variables while talking about data. So what is a variable? A variable is fundamental component of data analysis, and it refers to a characteristics of or attribute that can vary or change in the study. They represent the measurable quantities or properties that are being observed, measured, or manipulated. Variables can be different, can take different values, and their values can differ from one observation or individual to another. Let's look at the types of variables. There are three types of variables. We have the independent variables, also known as the predictor or explanatory variables. These are variables that are manipulated to or controlled by the researcher. They are believed to have effect on the dependent variable. Okay. In experimental studies, independent variables are intentionally manipulated to observe their impact on the dependent variable. For instance, in the study investigating the effect of new drugs on blood pressure, the independent variables would be the drug administration. So you see, you manipulate the drug that you are administering, you are manipulating the concentration given, and then you can now begin to check some other dependent variables, like you're looking at the effect on the liver, you're looking at liver enzymes, and so on and so forth. Now, the dependent variables are the variables are also known as outcome or response variables. They are variables that are measured on observed and to determine the effect of the independent variables. They are variables that the researcher is interested in studying or understanding. In the example that we gave below before, the dependent variables will be blood pressure, which is what you're being measured. So you put in a particular kind of drug, maybe you say drug A, B, C, D, depending on your hypothesis or your experimental design. A, B, C, but what you're measuring, you're not measuring the quantity of drug, because it is the quantity that you have administered is what you are checking the effect. So you are now checking the effect on blood on blood pressure. Now we have the control variables. Now the control variables are variables that are kept constant or held fixed during the experiment or the study. They are used to minimize the influence of the other factors that could potentially affect the relationship between the independent and the dependent variables. Control variables helps to ensure that any observed effect is due to the independent variables and not other factors. For example, in the study of the effect of a new teaching method on student performance, a control variable could be the factor like students' prior knowledge, age, age, and social economic status. Now, it's necessary for us to really understand that if you're doing any experiment, you must have a control variable. You must have what we might now describe as a control group, in which you're going to be using to monitor the effect of what you are doing to your variables. Okay. Now, in addition to these main types of variables, we have the categorical variables and we have the continuous variable. The categorical variables are variables that represent quantitative or categorical characteristics. They can take on a limited number of distinct category or groups. For example, like we said, category male, female, educational level, type of car, and so on and so forth. Now, when you're looking at this type of variables, it is not that you can call it independent variables. Okay, you can call it independent variable, but this independent variable already have categories. Okay, now you have continuous variable. Continuous variables are variables that represent quantitative or numerical characteristics. They can take on any values within a certain range. For instance, age, height, weight, temperature. In other words, when you take age, you can say between the young and the old. You will put the age bracket. If you're looking at the height, you're talking about the how tall or they are. You can, it's something that you can form within a particular range. Now, understanding types of variable is crucial for design studies. selecting appropriate statistical analysis, and interpreting results accurately. Different types of variables require different statistical techniques and methods for analysis. Now, we have also the hierarchical data order. The hierarchical data order refers to the organization or structuring of data in a hierarchy or nested manner. In this data structure, data elements are arranged in a hierarchy where each element has a parent-child relationship with other elements. This hierarchy arrangement allows for the presentation of the relationship and the dependency between different data elements. Now, when you're looking at hierarchy, for some of you that might have looked at dendrograms, that is a hierarchy kind of data. Okay, you will do it. You will have a kind of parent giving you various branches. Okay, sorry, I was not able to get a dendrogram this before this lecture, but anyway, you can always try to provide or improve, so you can just go and look out for it in the internet anyway. Now, in a hierarchical study order, data are organized in a tree-like structure with a with a single root element. So at the top and the multiple levels of the child element branch out from the root. Each child element can have its own child. Each child element can have its own child element forming the nest structure. Okay, this hierarchical organization can be visualized as an upside down tree, which the root of the top and the branches. I think I will make another video specifically for this for you to really understand. Now we have the binary data. In binary data, just like we learned about binary numbers, has just two values in it, the 0 and the 1. Okay, so we have some, depending on what the experiment it is, we have data that we can now describe as a binary data. You can read this up, but we just need to mention it, but it might not necessarily apply to us. Now you have the climatric and data type. Now, in climatric refers to the study that focuses on measuring of clinical phenomenon and development and evaluation of the measured instrument in healthcare and clinical research. So anything we are doing in clinical research, we call it clinimetry. Now, what we have done before about data types and data forms are applicable to this clinimetry research, so I will not go back. I just presented it here for you to know that it is the same thing, but this time around we are focusing on healthcare. So I don't know whether we have any questions. If you have any question, you can always drop it on the comment section, or you can drop it on your WhatsApp, the group WhatsApp, so that every other person can benefit. Thank you very much.